And this is my solution. So in here, I've gone ahead and created a new service, customer, image, Amigos code customer, latest, container name, customer, and basically everything the same as the rest. But the network in here, I've added Spring as well as Postgres, because customer talks to this Postgres container. So it uses this database. Now this is within this Postgres network. So therefore we have to include customer in the same network so that they can talk to each other. Then the same for fraud in here. So fraud. And also, so the port is 8081 instead of 8080. And basically I've also said that it depends on Postgres and RabbitMQ. So all of our microservices do depend on RabbitMQ. And I just want to make sure that if in the future these microservices need RabbitMQ, then there is a dependency between them. Then for notification is the exact same thing, but I've only changed the port. Now, you might have seen that within customer, src, main, and then resources, we have application-docker.yaml. This is now Postgres, the container name for our Postgres container. Then we have Zipkin in here. We have Eureka Server and also RabbitMQ. So RabbitMQ is the name of our RabbitMQ container. So if I scroll up, so RabbitMQ, and RabbitMQ has to be within the same network for Spring so that customer, if needs to, can talk to it. So that is it for customer. Then fraud. So fraud also has resources, application-docker. So this is basically the Eureka Server container name, Zipkin, and also Postgres. The same for notification. So notification, main, resources, and then application-docker, Postgres, Zipkin, and then here RabbitMQ. So this is the container name for RabbitMQ, and then Eureka Server. And to be honest, this is it. Now what I need to do is build an image for these, and let me clear my screen, dash, and then P, Maven clean package, build Docker image. There we go, success. Now, because we are using latest inside of our Docker compose, so have a look, Eureka Server, the image is latest here. The same for API Gateway, customer, fraud, as well as notification. So we are using the latest image. Now, what I want to do is pull the latest image from Docker Hub. So here, let me just clear the screen and I can say Docker compose and then pull. So this now will pull the latest images, and you can see that for some of them it already exists, and that's because it's using the cache and layers. So you can see that this was really quick. So now that we are done, let's just run docker compose and then up -d. So created container fraud, customer, and notification. And you can see that there is a dependency between them. And there we go, job done. Now, if I run docker ps and then format, and all of them are running, we can check the logs. So logs, and instead of Eureka Server, I'm going to check for customer. Oops, not Eureka Customer, but customer. There we go. So it looks like it started correctly. Have a look, create table, customer. So let's check fraud. Fraud also, create table, fraud check history. And we've got the banner at the very top, if I can see. So there we go, fraud. And we have for customer as well. And finally, notification. So let's check notification. And there we go. So notification started. And also more importantly, have a look, created new connection RabbitMQ. So this means that everything is up and running. Now let's fire up the same request from Postman. And before this request was 503 service unavailable. Let's try and send. And have a look. We have a 200 status code within Zipkin. If I check my traces, so find a trace plus service name. Now we have customer, basically everything. Let's select API gateway, run the query. A few seconds ago with 8 spans, show, and have a look. This is familiar. From API gateway to customer, customer to fraud, and then customer publishes onto the queue for notification, and then notification picks it up. So this is good stuff. Also for Eureka Server, if I reload, before we had API gateway only, now we should see all of our microservices. So this is working. And finally, let's open up pgadmin, and then I have to add in my password. There we go, open up servers. And in here we have notification. So I just want to check notification because I know we persisted in all of the microservices. So all rows, and check this out. Hi amigos, welcome to Amigos Code. And you can see the timestamp was literally just now. So congratulations, we've managed to take our code, bundle it into a jar, build a Docker image, and then run a container. But more importantly, we've managed to have all of our containers talking to each other. And you can see the beauty of Docker Compose. So in here, let's say that I want to stop everything. I can just say Docker Compose and then stop. So this will stop all containers. There we go. If you want to start, you can say Docker Compose start. Or if you want to get rid of everything, you just say Docker Compose and then down. So this is really cool. So Docker Compose is amazing for testing containers locally. Now, what you could do is, if you didn't manage to get everything running, you can take my exact same Docker Compose.yaml, and then in your terminal or command line, just run Docker Compose-d, and then all of this should work for you. And this is the beauty of Docker. If it works on my machine, it also works on your machine. If you have any questions for what we've done in this section, I know it was quite intense and lots of Docker, but this is pretty much the process that you'll be taking with Java applications and Docker. This is all for now. Catch me on the next one.